Hi students, welcome to this new video of tutorial 3 where together we will answer question 4 and also give an attempt to question 9. Now, in this question 4, you are given a set and the first question you are asked is to answer if S is dependent or independent. Okay, so to do that, right, we need to first define what we have seen in the lecture videos. When do we say that a set of vectors are dependent, right? When we have the sum of scalar alpha, alpha I for I, and then we have the vector vi equals to 0, where we have that alpha 1, alpha 2, alpha n, right? We have at least one of these scalars are non-zero, at least one, right? And for scalar alpha belong to R. And a set is independent if we have that alpha I vi equal to 0 for all scalar alpha equals to 0 for any alpha belong to R. Now, we therefore have this system as given. We have then to find to see if the scalar are all 0 or at least one is non-zero. So if we then put it in form of a matrix, right? Because we have that you can write this sum equal to 0 as alpha 1, 4, 3, right? Plus we have alpha 1 plus alpha 2, 0, 1, 2, plus alpha 3, 1, 7, 9, plus alpha 4, 2, 12, 15 equals to 0, 0, 0. Okay, we can put this in form of an augmented matrix: 1, 4, 3, 0, 1, 2, 1, 7, 9, 2, 12, 15, right? This way. Now, once we have written it that this way, there are certain we can now apply the Gauss reduction. So we can do that R2 is equal to R2 minus 4 R1, and then we do that R3 is equal to R3 minus 3 R1, right? And this will give you 1, 0, 0, right? And 0, 1, 2, and 1, 3, 6, and 2, 4, 9. And I still have my 0 here. The next thing I have to do here is to do that R3, right, equals to R3 minus 2 R2, because I need to have a 0 over here. So this will give me 1, 0, 0, 0, 1, 0, 1, 3, 0, 2, 4, 1, and I have 0, 0, 0. Okay, what do I notice here? Here I have a leading entry 1, I have a leading entry 1, and I have a leading entry 1 here. So I have alpha 1, I have alpha 2, I have, um, I have alpha 3, and I have alpha 4. So I can see that alpha 1, alpha 2, and alpha 4 are fixed variable or pivots, but alpha, alpha 3 is a free variable, right? Therefore, if we have a free variable, right? What does that mean? It means that not all the scalars are zeros, right? So this means that we have a system of infinitely many solutions. Therefore, the set S is dependent. Okay, right. Now, so now we have the second question. We say that look again at your Gauss reduction, right? If you want an independent subset of S, right? Um, which three vector could you use? Which three vector could you use? Let me rewrite the matrix here, the reduced matrix here. I have that is 1 0 0 0 1 0 1 3 0 2 4 1, right? So I observe and I see that I need to remove this column, right? So that I can choose three vectors 0 1 0 0 0 1 0 and 2 4 1. Sorry, 0 0 0. So if I have this, I can see that I have lazy entry here, here, here. So all of this will be fixed variable. So I will have that alpha 1 equals to alpha 2 equals to alpha 3 equals to 0. So these are the three vectors I will choose to have a independent set. Now, let me give you some hints on question 9, right? In question 9, you have also an homogeneous system, AX equal to 0. Now, you are asked to find the basis and dimension, right, of the solution space as 1, 3, 3, 4, 3, 9, 4, 2 of X equals to 0. Now, how do you solve such equation? You have to find the basis and the dimension. So the first thing to do here is to apply what we all know, the Gauss reduction, right? So which operation will we apply here? We can see that we can apply that that R2 equals to R2 minus 3R1. If I apply that, I will have 1, 0, 2 minus 2, 3, 0, 4 minus 10, and I have my 0. Then I can see, right? I can see that I can divide this line by minus 2. In other case, I have 1, 2, 3, 4, 0, 1, 0, 5, right? Then I can do that R1 equals to R1 minus 2R2. This will give me 1, 0, 0, 1, 3, 0, minus 6, 5. And I have 0 here. So what do you notice? Here I have leading entry. So so if I have x1, x2, x3, x4, right? So if I have all those values given there, I can see that x1 and x2 are fixed variable, and um, x x3 x3 and x4 are free variable. So x1 and x2 are fixed, x3 and x4 are free. So x3 equals to c and x4 equals to s. So from the second row equation, I have that x2 plus 5x4 equals to 0. And from the first row, I have x1 plus 3x3 minus 6x4 equals to 0. This leads me to x2 equal to minus 5s and to x1 equals to minus 3t plus 6s, right? So if I want to write my solution, x1, x2, x3, x4, this will give me, right, minus 3t plus 6s minus 5s t s. So splitting it, I have this minus 3, 0, 1, 0, and then I have that s 6 minus 5, 0, 1. And with the t and x scalars. So I have the solution given here. So you can we can check from here, right? And we can see that we have a solution with these two, right? And we can see that these two vectors are linearly independent. And because they're linearly independent, therefore, they form a basis. If we call this V1 and V2, therefore the basis will be V1 and V2. And the dimension of the basis will be the number of elements in the basis, that is dimension equal to 2. Right. So I hope this gives you a clear understanding on how you will be able to solve the rest of the questions. Thank you.